Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS. In the previous lecture, we did some of the questions based on the forward differentiation method. In today's lecture, we'll start with a new concept, which is Newton-Gregory forward interpolation formula. What is Newton-Gregory's forward interpolation formula? Suppose we have a function fx where x has the point on the points of a series which is a plus h, a plus 2h, up till so on a plus nh. The all the total terms of this is n plus 1, because from 1 to n it is 1 and this first one is plus 1. So let us have a series of n plus 1 terms which are a plus h, a plus 2h. A is the starting point of the series, and the series is increasing with the addition of a constant which is h. And h is a very small value. We consider it is a very small value, and this is the function on this series. Now we have to find out the forward interpolation and this polynomial. Let us say that fx is a polynomial of degree n. Right? Fx is a polynomial of degree L with n plus 1 terms. So from this, one concept is clear that for a polynomial, suppose the polynomial is of degree n, we need n plus 1 terms. Suppose the polynomial is of degree 2, we need 3 terms. Suppose the polynomial is degree 3, we need 3 plus 1, which is 4 terms, and so on. One concept is this, and the second is we have to find out Newton-Gregory's forward interpolation formula. Suppose we have to find it a value which lies somewhere in between this a plus uh. Now h is smaller than n but bigger than 2 and lies between both of them. So we have to find out this. Suppose we have been given a series of suppose 50th term, 60th term, 50th term, 51st, 52, and so on. And the last term we have been given at 60th. But we have to find out what is the term at the 61st number. This we have to find out. Then we'll use Newton-Gregory's formula for this, forward interpolation formula for this. In statistics, as we use for interpretation, we are using something for interpreting some values. We use data for interpretation. Similar in Newton-Gregory's forward interpolation formula, we are estimating a value based on the previous value, just like we do in time series, just like we do in our SQC, statistical quality control, just like we do in ANOVA and all those things, the basics of statistics. Hence, we are doing it in Newton-Gregory's formula in numerical analysis, and hence numerical analysis is included in statistics. It is a mathematical term. Okay, so I'm just writing the Newton-Gregory's formula, which is if we have to find f a plus uh, then the formula is simply fa plus u into delta of fa plus u into u minus 1 upon 2 factorial. Here it will be 1 factorial. That's why I didn't write it. Delta square fa plus u into u minus 1 into u minus 2 upon 3 factorial delta cube fa, and so on till the last term, which is u minus 1, u minus 2, and so on till u minus n minus 1 into delta raised to the power n fa upon n factorial. This is our Newton-Gregory's formula for nth terms. And we'll do two numericals based on this, so that we'll be clear with all of them. In the exam, directly questions has been asked. Suppose we have been given the value. Suppose we have been given a table like this, in which they have given us the value of theta and sine theta. Suppose the value of theta, suppose the value of theta is 0, so sine theta will be 0. Suppose the value of theta is 30, 60, and 90. Value of sine at 90, sine 90 is 1. Value of sine 60 is 1 root 3 by 2. Value of sine 30 is 1 by 2. This is the value. Now, if we have to find out the value at theta equals to 108, then what? Then we have to find out sine theta, and without the table we haven't learned that, so we'll use these values to find out 108. How? Then what is the value of u here first? If we put a plus uh as equal to 108 here, because we are finding 108. If we put a plus as 108 degree, then a first term is our 0. A would be 0, plus u we don't know, and h, the difference between them. As we see here, the difference between them is of 30. So into 30 equals to 108. So our u will be equal to 108 upon 30, 3.6. So we have got u. Now we put the difference method here. We'll put up till this 90 degree, which is 1, 2, 3, and 4, which is delta raised to the power 4. No, 3 only. 1, 2, 3, and 4. 4 terms. Okay, that's how we calculate it. Let us take an example to understand this type of question in detail. Suppose we have been given a value, a table. The question is in first two columns. I'm writing the question. We have been given the year, and the population of a city. In year, in thousands. Population of a country in thousands. In year 1891, the population of the country was 46,000 in thousand. Okay, this is nothing but, instead of population we can also write this as fx and this as x. Okay, so in 1891, 1901, 1911, 1921, and 19 31. These are the years that has been given: 66, 81, 93, 101. Okay, so this is the question that has been provided to us, that we have been given the year as 1891 to 1931 with the gap of 10 years, and the population as fx in thousands, which is 46, 40, 66, 81, 93, and 101. Now in this question we have to find out the population for the year 1925. Now, first of all, let us see. We know the formula as FA plus NH should be equal to FA plus U upon 1 factorial delta or of FA plus U into U minus 1 upon 2 factorial delta square of FA, and so on, right? We are not writing the nth term. Here we have been given that A plus UH should be equal to what 1925. Now the first year that has been given in the question is 1891. So I am putting here it as 1891 plus U into H. The difference I told you is is for 10 years, and 1925. 10U should be equal to 1925 minus 1891, which is equals to 34. 10U, and U must be equal to 3.4. We have got the value of U from here. Now we'll find out the deltas. We'll keep on finding out the deltas until we get a constant term. So the first column will be of delta fx. The second one will be of delta square fx. Third will be of delta cube fx. And fourth will be of delta raised to the power 4 fx. Right? So the first difference will be 66 minus 46. The bigger one minus the lower one. So it will be 20, and we'll write it in between. Remember that. 81 minus 66. 81 minus 66 will be 15, and we write it in the center. 93 minus 81 will be 12. 101 minus 93 will be 8. Okay, we have got this. We are slowly doing this just so that you know the exact procedure, and as and when you will practice these kind of questions, you will be thorough with the concept, and you will be able to do in seconds or minutes in the examination. And they don't ask you for too large of a calculation. They ask you for just little calculation, so that you can complete it within time. Okay, since the question paper is of objective type, not much amount of work will be required. In this question, it is required to calculate delta raised to the power 4 fx, but in that you will be only required with 2 or 3, maximum 3, not more than 3. If it is for more than 3 or 4, 5, then you can just simply ignore that question and don't waste your time on these kind of questions. You can do simpler ones. Okay, so let's get back to this. Now second differentiation will be this minus this. 15 minus 20 will be minus 5. 12 minus 15 will be minus 3, and 8 minus 12 will be minus 4. Now if we again subtract it for delta cube, 3 minus 3 minus minus plus 5 will be 2, minus 4 plus 3 will be minus 1, and here we'll get the final answer: minus 1 minus 2 will be minus 3, and furthermore we cannot do, so we'll stop here. Okay, now moving forward to putting our values here. So f of 1925 will be equal to fa. So the fa was 46,000 for the first year, so we'll take it as 46. We will do the thousands in the last. Plus u is 3.4, into delta of FA. Delta of FA, first delta is first portion. The first part of delta of Fx is 20. So we'll multiply it by 20. Then we'll add u. U minus 1. So u will be 3.4, u minus 1 will be 2.4, and delta square of f will be minus 5. So we'll put it here minus 5 upon 2 factorial. Plus u will be 3.4, u minus 1 will be 2.4, and u minus 2 will be 1.4 upon 3 factorial into, we'll multiply with the next first term, which is 2. Then we'll add another one, which is u minus 1, u minus 2, and u minus 3 upon 4 factorial into, the last difference is minus 3. So it will be minus 3. And as and when we calculate this, we'll get our answer equal to as 96.83 something. So in 1925, the population of the country Y will become 96.83 in 1000. Okay, this you have to mention, or just you have to find out this because it is an objective type. For the ones who are doing it for subjective type, I would again tell you that we are just doing it in detail for the very first time, since you don't know the concept, and I am taking it from the very basic level just so that you can know what has to be done in here and how to attempt the kind of question that has been asked in the examination. They'll just simply give you a table, and the questions are like this. They'll give you a table. They'll give you x, fx. X is 1, 2, 3, 4. Fx is 12, 11, 9, 7. Suppose fx is this. I'm just supposing. Let us take an example. So they'll ask you what is the value of f7, where you have to find the 7 value. Then you will use Newton-Gregory's forward interpolation formula. Or they can ask you, suppose you have to find 11, or suppose you have to find 100. The ones they are asking are easier in calculation as compared to the ones we have done in the class. Just so as to make your concept clear, I have made you do that. So you can check for the PYQs and start attempting those kind of question. And you face any doubt, then you can ask in on our WhatsApp channel. We'll sort your doubts as and when we see that. So this was the concept, and this was the kind of question. We'll take 1 or 2 PYQs on the same concept, so that you will be thorough with the concept and how to solve it in the examination. And I hope that whatever we have done today in class are clear with all of you, and if not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. And about our Lakshya 2027 batch that we have just launched, you can many of the people are enrolling in that batch, and the seats are limited because we have told that we take only selective candidates and not all of them. So if you are interested and if you are disciplined enough to prepare for ISS examination, then you can enroll in the batch. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.